All right, so I wanted to make a quick video here. Obviously, one of the things coming up is the final exam for Iowa Western. This is the final exam that you would normally take if you had taken the actual class at Iowa Western itself. It's one of the requirements that Iowa Western has in order to get the credit, the college credit for this class. Now, there's a couple of quick things that I wanted to talk about that we haven't talked about throughout this semester that you're going to see on your final that are pretty couple of simple things, but I wanted to make sure I touched on those before we actually took the final exam. So the first thing, first kind of extra thing that you'll see on the final exam is this concept of data that is continuous versus data that is discrete. If you've taken college algebra or calculus before, you might remember talking about the idea of a continuous function, and it kind of has a similar meaning with data. Um, so as it says here, data is said to be continuous if the values belonging to the set can take on any value within a finite or infinite interval. What does that mean? Essentially, what that means is it's data that is measured. Okay. This is just something I stole from Google Images. You measure the height of a child, you measure the length of a leaf, you can measure the speed of a train. All of those examples would be data that is continuous, whereas data that is discrete. A set of data is said to be discrete if the values belonging to the set are distinct and separate. Essentially, data that is counted and not measured is considered to be discrete. So the examples here: number of languages spoken, number of books on a shelf, number of people in a family. Those are all things that are counted. Each number is distinct and separate. You would never say you have 3.2 people in your family. You would say you have 3 people or 4 people or 5 people. So data that is counted is considered discrete. Data that is measured is considered continuous. Okay. Next thing we want to talk about, and I'm going to go from bottom to top on this, are the 4 different levels of measurement. So we will start at the bottom here with data that is considered nominal. The prefix nom, N-O-M, actually means name. So nominal data is where we have data that falls into categories, but there is no ordering or no direction, where one category means is somehow ranked higher than the other category. So the example they gave here is marital status and type of car owned. Those would both be examples of nominal data. Ordinal data, the next one up, ordinal sounds like order. The data also falls into categories, but there's a clear ordering involved, where one category is clearly ranked higher than the other category. Obviously, the most obvious example here would be a letter grade. An A is clearly ranked higher than a B, which is clearly ranked higher than a C. So ordinal and nominal data both have to do with data that is measured into categories. Okay. The difference being nominal data, there's no sort of ordering or ranking involved, but in ordinal data, ordinal sounds like order, there is an order or a ranking involved. Okay, so that is the first 2 here. The third one, interval data. Okay, interval data and ratio data kind of go together. Okay, so interval data is we can have differences between measurements, but the big difference is there is no true zero. Okay. And one of the examples they give here, whoops, is the temperature in Fahrenheit. Okay. Um, when you measure temperature, your temperature can go as high or as low as you want. There is no true 0 degree temperature. You can have a temperature below zero. You can measure a temperature below zero, and it can go as low as you want. It can go as low as negative infinity, right? There is no true zero. That would be considered data that is interval, okay? When we have a true zero, when there is a true zero, we call that ratio data, okay? True zero exists. For example, um, someone's height, okay? That is something that's measured, but there is clearly a minimum height for a person, right? There's clearly a minimum age. Your age can't go in the negative. Um, Weekly food spending, you could choose to spend $0 on food for the week. Okay, those would all be examples of ratio data. So interval data and ratio data are data, again, data that is measured. Um, but the difference being interval data, you don't have a true zero. And in ratio data, you do have a true zero. Okay, so you will see at least one question on these different levels of measurement on the final exam. The last thing I want to address is going back to confidence intervals, which we talked about in the very last unit, chapters 17 through 20. Um, One of the things we didn't spend a lot of time on is the margin of error for a confidence interval. Obviously, we talked about how to find a confidence interval on StackCrunch. If you forgot, remember that was the one that involved going either to proportion stats or T stats, depending on whether it was a proportion or mean. And we would go to 1 or 2 sample with summary, and we could find a confidence interval here by putting in all the pertinent information from the problem. Okay. So if we wanted to find the margin of error for a confidence interval, we would find the confidence interval like we normally do on StackCrunch. Okay. But as it says here, the margin of error is half the difference of the upper limit and the lower limit. So remember, when you get your confidence interval, you get your lower limit and your upper limit. The margin of error is half the difference of those two. So in other words, that would be your upper minus your lower, half of that divided by 2. So you will see a question on the final exam where you're either asked to find a confidence interval, and you can use StackCrunch for that, or you're asked to you're given a confidence interval and you have to find the margin of error. And this right here is how you do that.